Hello. I'm taking a bit of a break with my beginner Java series to start a learning Clojure um, a streaming series because I wanted to get more familiar with functional programming for a while now, but I just didn't have the time or I ran out of motivation and stuff like that. So I hope that now that when I'll be streaming my progress, that I'll be able to stick a bit longer. So what I'm doing is I have a VirtualBox running, and I installed X Ubuntu on it. It's a pretty fresh installation. I don't even have Java installed, so I'll be basically doing this really from scratch. But it's worth mentioning that I'll be doing this massive open online courses from the University of Helsinki from Finland. They have this great course on functional programming with Clojure, and the part I like is they say that no prior experience with functional programming is required, just as I would like it, because I really don't have that much functional programming experience. So um, that's it. Well, let's get started, and I'll start installing all of the required tools like Java, text editors, and stuff like that. Right here we go to basic tools. They say we have to first install Java, assign editor, Git, Leiningen, make sure we have a GitHub account. I do, and we have to very carefully read the instructions. So first of all, we have to install Java. Just let me check that I really don't have it. Java. I really don't have it, so let me just Google it like any good programmer. Install Java on Ubuntu. Let's go. This seems a good link. Okay. I think I'll just install the OpenJDK. I think that's what I'm supposed to. So sudo install OpenJDK. Yep, I think that's gonna take some time. It's okay, we can check other things. So while we're installing Java, we have to let's check this out. What's Leiningen? It's basically a package manager for Clojure, so we'll be installing that later. And they're recommending light table as an editor. Since I don't know Vim or Emacs that well, I guess I'll just use this. Download that. Oh, this is taking all of the bandwidth. Maybe I should have installed this before I started streaming, but oh well, I'll pause this for now. So yeah, I think streaming puts a real strain on my internet connection, as you can see. Oh well, let's go forward with this course and wait for this to get installed. So this is how to set up our editor. So since we don't have it yet, right? So since, well, this is gonna take some time to install. I was hoping that it would be faster, but since it's taking its sweet time, so we should just, I don't know, read up on Clojure, I guess. So for Clojure, I think that's a website for doing problems in Clojure. So maybe we can do a few problems here. Okay. So we have elementary problems. So this is a Clojure form, enter which will make the form evaluate to true. True is equal to true. Who knows? Okay, run. And we have a winner. Great. Simple math. Okay, so yeah, Clojure is using something called a Polish notation, which means that the operator is not infix like we're used to, but it's actually prefix. So the operator is before the numbers. So this would evaluate to 2 times 3 is 6, and 10 minus 6 is 4, I guess. Okay, we got that right. Intro to strings. Clojure strings are Java strings, so this means that we can use any Java strings on Clojure strings. Okay, so what this would probably do is this. Whoops. Hello world. Yay. Let's see our progress. Whoa. Great stuff. It's already unpacking. So let's continue with our function. I mean, our Clojure exercises, and let's see. Now this, I don't know what any of this means. So I'm just gonna skip this. Let's see, hello world. Write a function. I don't know how to write functions in Clojure, not yet. So I think we just have to wait to install and to get on with our course. I'll just close this for now and let's see if we have Java installed. Java minus version. And we have, let's see what about Java C. And we have, great. Let's try downloading light table again. And of course, we have some luck with our connection now. So we should get on with our, all right, so we have to go to our home directory and let's say if we have our bin directory, we actually don't, so we have to create our bin directory and we have to add it to our path, so we will do that. We will open our, I'm using the Z shell, so I'll add it to Z shell RC like this. I'll open it in Sublime Text. And I'll just paste it right here. This I'll add a comment, adding bin directory to our path. Like this. Okay, what's next? We have to reload our ZHRC. Okay, that's done. And we have to download this script. So I'll basically just copy this, make a new file, and I think I need to call it oh, I have to save it in our bin directory, so save right here, and I have to call it line like this. Save. Okay, I have to make it executable. Oh, chmod +x bin line like this. Okay, now it's executable, and now I think I just need to run it. So line help should work. It actually doesn't. That's weird. So if I go to bin and say line help, chmod +x, if we say line help, still no. Let me just then echo our path and let's see. I don't think we, let me try and restart the terminal and echo the path now. So we didn't actually add our bin. So let me try and do that. If I do it here. Oh, and now it did it. So what if I do this now? Oh, and now it's working. So I think, yeah, there's a problem with my with this config file. I'll figure it out later. But for now, I'll just do it this way. So you'll have to wait to install all of this. Oh, we have this downloaded. So I'll just unpack it here. Mhm. So open a terminal here and start light table. Nope. Have to do it like this. And we have liftoff. Okay. So we have our terminal, or I mean our text editor opened. So I can close this. But I'll leave this terminal open. Okay, and I think we have lining installed. Yep. Okay. We can go just minimize this. And I think I should have Git installed. What is it? Okay. The start of each chapter or GitHub. Okay. Okay, so I should fork this repository. Right. Okay, so I should fork this here. Great animation. Okay. I think it's done. So what I should do now is clone it. Okay. So I'll just copy this URL, go into my terminal. Let's see. Okay, I'll just make Clojure learning like this. I'll change the directories and I will git clone, copy this and into a folder called training day. Like this. Okay, we can go inside. Let's check out what we have here. So, okay, but now will be created. Go inside the directory and issue this command. So lane midget like this. So okay, I think yeah, it has to download it. Right. Okay. We're now ready to start working with the exercises. Whenever you encounter an exercise in the material, open the file source training day and fill the appropriate function. Okay. Oh, that's not it. Oh, it's still downloading. Okay, so right. Okay. When you open the light table, you want to open your project. So view. Apparently it doesn't like me. Let me just try and so if I run no. What's light table? Right. So I think I should Google this since I'm getting something. Right. So let's see. Oh, this ended up downloading. I don't know why my light table is not performing, or I mean opening. So I guess for now I'll just use the Sublime text, and I'll have to figure it out some other time. So if I go to I'll just close this project and I'll open not file but open our folder. I'll go to Clojure Learning Training Day and I'll open. So nope, that should go right here. So let's see, answer at line 6 expected was 42, so I think I should replace that with 42. Let's run this again. I hope it doesn't have to download it again. Okay, so now we only have 5 checks failed. Okay, so I think there's a command to auto test. Okay, so if I do line midget auto test like this, it should run the tests every time I make a change. Okay, so what's next? It said, okay, so square. It at line 11. Wait, what? All right, so this function probably returns x squared. So if we use the Polish notation, this should look like something like this, xx. So we just multiply x times x, and I don't know, I'll just run it the old-fashioned way. And I hope it works. Right. Oh, so I think, all right. I think it would be better if I actually open the REPL. Let me see if I can get it. Read, execute, print, loop. Yeah, if I could open that. So if I type REPL, nope. Right. Let me just check. Oh no, I think it's line REPL. I hope I got. Oh, it worked. Great. So now if I type use training day, okay, and if I type square 7, I should get 49. Yes, it worked. Oh yeah. Okay, so I think we have one function left. Okay, the average. So the average of a and b is a plus b divided by 2. So I think we will have a division, and we will divide the sum of a plus b by 2. So I don't know how to add make comments, but this will add a and b, and then it will divide them by 2. Okay, we open a new tab and run our tests. Right, because I don't actually have, but let me just check the average of, let's see, 10 and 5. Average 10, 5. Oh, right, I have to reload. Maybe this? Still no. Okay. Maybe I should just run the tests. Bye for now. Lane, mid, like this. Pum 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 pum. These tests are taking a really long time. Oh, check succeeded. Yay, we got our first project in Clojure working. Okay, so we should proceed. Let's see. Oh, oh, they actually tell you how to solve this. Okay, that was my bad, I guess. But still, we can go over the what they were saying. So, oh, so the midget testing library. So, right, this is the testing library we're using to test our code. So, right. Following. Oh, this is what I was talking about, the prefix syntax. So instead of writing 1 plus 2, you write it as plus 1 and 2. It maybe seems a bit counterintuitive, but it's, well, once you get the hang of it, I think that it should be pretty easy. So, okay, so we have a couple of exercises to do. So we can run our line REPL again. And we can try and type these two expressions. Okay, so they want us to type this. So what this does is multiplies 2 and 3. So we will have plus, like this. And then we have multiplication of 2 and 3 and 4. And this should give us 10. Yes. And now we have this. So let's see, plus plus. So I think another plus of 3 and 4, and then 5, and then 6, I guess. Nope. Oh, right. 18. But I think it also works if I just give it like this. So 3, 4, 5, 6. Yeah, it's a bit more cleaner this way. So write the Clojure expression in the REPL using get. Gets the first character in the string abracadabra. Okay. So, well, yeah, we just basically use this. Okay, so get abracadabra 0. We got A. Great. So in Clojure, the function name always goes first and the parameters come after it, including the objective such as present. So yeah, the Clojure syntax might take some time to get used to. So if you're used to object-oriented programming, as I am still, it looks pretty weird, but let's see. Let's go over functions. So this, since it's functional programming, I'm guessing that it's pretty important to understand how functions work. So let's start writing a function hello who, which returns an English greeting to the user. So functions are created with fn. Okay. So if we type the following, so if we type fn who string hello, so this will basically convert it to a string, all of its parameters, like this. Okay. So what kind of function did we actually get? The square brackets are the parameters. So this is the parameter, or the who is a parameter. Like in Java, it would probably string who. And right after that comes an expression, a call to a function string in this case. So this is the parameters and this is the function body, I would guess. So in general, the return value of a function will be the value of the last expression in the function. So yeah, if you ever used Ruby, I guess it's similar as there, where you don't have to explicitly type in the return value. You just do an expression or some operation, and it will automatically become the return value. So we have a function, so let's call it. Okay, so if we do this and let's see. Okay, so we have to put another bracket, and let's say my name, like this, and it says hello rock. Okay. So the function, as you can see, is always is the first, and I gave it an argument of my name, and it produced hello rock. Okay, so let's call this function with our name. So another bracket, and this, welcome to Rivendell, Mr. Rock. Okay, now we know how to make a function, but we only got a glimpse of it. So, oh, right, so if we declare a function with a keyword of fn, it's an anonymous function. So I guess it's kind of like a lambda function, or anonymous. So to give a function a name, we have to use def. So I guess to define a function. So let me bring back this, and we have to write another bracket, close it. And if we write def hello, oh yeah, we defined the function with this function, and it's binded to this keyword hello. So if we type hello beautiful like this, it should produce hello beautiful. Great. So what just happened? Well, the dev gives a name to a value. In the previous case, the value is what we get when we evaluate this. So exercise 5. All right, we actually did this. So as you can see, they actually have another keyword for making this shorter. So to join these two steps of defining a name for the function and actually declaring a function into one step, you can actually do something like def and hello gives out personalized greetings who and string hello who like this. What? Okay, so right, so here hello is the name of the function, who is the parameter list. Right here, this is an optional doc string. So if you're it's the description of what the function does. So for comparison, this what this function looks like in Java. Yeah, so string hello, it returns a string, it takes in a string, and it returns hello plus who with an exclamation point. So in Clojure, there is no return keyword. So the return value of a function is always the value of the last expression in the function body. Oh, whoops, a bit too far. Okay, so we're at files and namespaces. So so now we will actually submit. So coding Clojure project is structured into a namespace. A namespace is defined in files. Usually each file corresponds to one namespace. So the repository that you cloned at the end of the last chapter contains a lining and project. So inside the source folder right here is our source code, like this. So we have to, oh, this is a namespace definition, right? So we do when we did this so that we specified when we opened our line REPL that we will be using the source code from this, so that we can execute those functions. Okay, so right now we actually have to, let's say, get status. Okay, so we add, so get add, or we can do just get minus a minus m. Let's see, training day completed, like this. Oh right, I forgot to get commit, like this. Okay, and we have to get push. This. Okay, so let's check that. that the commit really did happen, and yes, we did. Okay. So what now? What awaits? So we have to go to our GitHub page of our fork, click on the compare and review. When we are ready, send pull request. Okay, so we have to go compare and review. Okay, and we have to create a pull request. Okay, so we probably have to click this. Okay, I think that's it. Create pull request. Okay, so we are waiting to hear. Oh, right. So what it's doing now, it's Travis continuous integration is checking our code to see if we indeed got our answers right. So it's checking to see if it can be merged. So if we really did complete the training day, or if we have to make any modifications. I hope not. So let's see. Should be. Let's refresh. So we have to wait. While we're waiting, we can go on to the next page. Proceed to the horse feast. Okay, so any program is only as good as it is useful. Linus Torvalds. Good. Okay, so let's see. All is well. The Travis continuous integration build passed. So we actually did complete. So yay for us. Okay, so we have to fork this now. So I'm a horse in the land of Booleans. Okay. Fork into my profile. Let's wait a bit. Right, so here are the instructions if you need them, or I don't. So any non-trivial program needs conditionals. Yeah, that's true. So if my father is Darth Vader, lose hand, gain hat. Right, so I think I should open. Oh, right, I should clone my project now. I should go back into my Clojure learning folder, and I should do git clone into, let's say, just land of booleans like this. I can move into this folder, and I will just open it in my Sublime text. Wait, land of booleans like this. Okay, source. So we'll have to complete this. So let's see. If usually takes three parameters, the conditional, clause, the then body, and the else body. If the parameter, the conditional clause is true, then the then body is evaluated, so it's a pretty standard. If, so Clojure has two Boolean values, true and false, just like Java. However, Boolean context, like if, everything except a nil and false acts as true. So if we say if we have an empty list, I'm presuming this is true. So, but if we have if false and if nil, that's the only thing that will evaluate to false. So nil is actually Clojure's null value, right? So exercise 1, implement Boolean x, which works like the built-in Boolean function For nil it false, it returns false, and for all other values it returns true. You can use if in its implementation, but not the built-in Boolean. Okay. So we should do this exercise, I guess, in our REPL. Let me just run it. Right. Okay. So what we have to do is implement the Boolean, this Boolean function. So if we do this and Boolean, I guess, and we have to have one parameter. So I hope we're right until now. So, and if we type, let me check just how to write an if function. Okay, right, like this. If, just close it. So if x, so if x is, so the only thing that evaluates to false are, so I can basically do this. So if x will be truthy, we can return true, otherwise we return false. Okay, so we actually replaced that function. So if we type Boolean foo, this will return true, and if we type Boolean nil, it will return false. Great. Okay, so comparing values, we can do that by the equals operator. So if we do foo, oh, missed that. Like this evaluates the true, and if we do foo bar, false. Okay. So I guess 42 is equal to 42. 5.0 is equal to 5, and okay, so the double equals operator disregards the actual type, and if we have just one equals sign, it actually requires them to be of the same type, I guess. Okay, and we have standard greater than, or equals, and all of that operators. Okay. Oh, this is great. We can true if and only if x equals to y and y equals to z. And this is true if, well, this is if these are in descending order. So if x is smaller than y, y is smaller than z, and z is smaller than q. So we have to write the function teen age, which returns truthy if age is at least 13 and at most 19. Use only one comparison operator and give it 3 arguments. Okay, so let's try if we can figure this one out. So we have to define a new function, call it teen, right, and it will return true if age is at least 13 and at most 19, and we have to use only one comparison operator. Right, so how do we do that? Okay, so we also get one argument, x, and we probably have to have an if, so for so we have to Right, so we have to use only one comparison operator and give it 3 arguments. Oh, right, so if we do this, so if like this, so x 19. So if x is bigger, or I guess equal to 15, like this, so I think that should work, right? So if we type 12, it should return false. Whoops. If we type 13, and it returns true. Yeah, so basically I just use this, and this checks if x is between 13 and 19. Well, equals to 13 or 19. Okay, great. So everything has a value. So in functional programming, and specifically in Clojure, everything is an expression. So, right, as an example, let's define the function sin x, which returns the string minus if x is negative and otherwise plus. So the function looks the following. So let's see. We define a sine function, and we have a parameter x. So, and we say if x is smaller than 0, we return a minus sign. Otherwise, if it's 0 or bigger, we return a plus sign. Okay, and we can actually copy this, paste it in our right here. We can try by sign, not sync, but sign 2, and it returns a plus. If we try sign 0, returns a plus, and sign -2, it returns a minus. Okay, there is no need for a return clause. There is no such word in Clojure. So we have a watch out. If does not have a return statement, yes. For the illustration, you could use Java's if to implement sign. So this would be an illegal expression in Java. So you have to have this return statement. Java doesn't automatically assumes that the last evaluated expression is the one which will be returned. Yeah, so okay. Conditional evaluation. In any case, only the appropriate expression is evaluated. So the following is not an error. If evaluated, would throw arithmetic exception due to division by 0. However, right. Okay, so we have to write, another function called absolute, which actually just returns the absolute value of parameter n. So if we type, so with standard, we define the function abs absolute, which will take parameter n. I'll just break it out a bit, and then we actually have to check if our n, right, if, let me just check how to write this. All right, so we have to put it in brackets. If n is smaller than 0, what we have to do is return n multiplied by -1. So we return a function. So we evaluate this by like this. So we multiply n by -1, and if it's bigger or equal to 0, we just return n, I guess. So how many should I have like this? Okay, so let's see if I actually implemented it correctly. So if we type abs -2, it should return 2. Yes. And if I type say 32, it returns 32. Great. Now we have to write the function divides divisor n, which returns true if divisor divides and false otherwise. Okay. Right. Okay, so this should be start by defining a function. Define divides ? Then we'll take two parameters called divisor and n. Whoops. Too much. And we have to check if divisor divides n. So so we have to check if the remainder when we will divide our n and divisor is equal to 0. So what we have to do, we have to check if mod of n and the, oh, I misspelled, so I have to div like this. So if this will be equal to 0, so I'll have to do this. If it equals to 0, if this expression is equals to 0, we return true. Otherwise, we return false, and we have to do the closing brackets. Oh, and we got unable to. Oh, I forgot. Oh, my bad. So let me do this again. I forgot to do this. Curly brackets, or I mean brackets, are very important in Clojure. I should not be forgetting them. Like this, and right, and 0. No, whoops, I should put the 0 in here. Like this, and now, right, true, false. This closes the if statement, and this closes the define. Right. Okay, so let's test it out. The divides if whoop, forgot the question mark. So yeah, 4 is divided by 2. Let's check if 2 is divided by 4. False. Let's see if 10 is divided by 5. Yes, it is, and so on. So when we are checking for multiple conditions, I guess there is no else if. Oh, so the general form of condition, I guess this is the way to write the else if statement. So this would be if, else if, and stuff like that. So like with if, you can have an else branch at the end. The condition for the else branch is else. Oh, so you have to type a colon and else. So right. Okay, so we have to write the infamous FizzBuzz function. So we have to print out fizz when n is divisible by 3, buzz when n is divisible by 5, and gotcha when n is divisible by 15, and an empty string otherwise. So we can use the divides function, which we defined in our previous exercise. Okay. So what we do here, we define our FizzBuzz function, our name, and we will give it a single parameter, enter. So now we have to check. So we will probably have to use this form, our condition form, to check if n is divisible by 3, 5, or 15. So condition. So, and we have to do divides like this. So a question mark. I shouldn't forget that. And if 3 divides our n, we should return fizz like this, I guess. Right? Forward. Let's do if 5 divides our n, we return buzz like this. And if 15 divides our n, we return gotcha like this. And we have to have an else part where we return an empty string, and we have to write the closing bracket and another closing bracket, and I think that should be it. So if we try with FizzBuzz 2, it should return an empty string, right? If we try 45, it returns fizz. Right. Why is that? Why we got fizz, but we should have gotten gotcha. I guess we should have moved the 15 conditional to the first place, because 45 is divisible by 3. Yes, it is. And by 5. So let's check 48. It returns fizz, yes, and 70 should return buzz. Okay. So I think we just need to move this to the first conditional. Okay. So another exercise. Write a function, generic duplicate, that takes one argument and doubles if it is a number, returns nil if it's an empty collection. If it's a list or vector, returns 2 times the length of it and returns true otherwise. So you can use the following function. Number n returns true if n is a number. Right. Okay, so this will be a slightly bigger function. So let's try that out. If we write, so we define a function called gen double. I'll just shorten it a bit. Takes one parameter x, and you'll have to have a number of conditions again, and we type. So if it's a number, like this, if x is a number, returns true. No, it doubles it. Okay, so we have to do x. We return a doubled x like this. If it's nil, so if it's empty, so if it's in an empty collection, returns we return nil. Okay, so if it's a list, so if x is a list, we return double the length. So we have to do multiply, count x and 2 like this. And if it's a vector. If x is a vector, we do the same. We do count x, and we multiply it by 2, and the else part just returns true, and we close our brackets. So this, I guess it works. So gen double, gen double of 1 returns 2, right? And if we give it a list or a vector, I don't know yet, it returns 4 because we have 2 elements, so the length of this is 2, and we multiplied it by 2, which returns 4, and so on and so forth. Boolean function, we have the keywords and or not, which correspond to this, this, and this in Java, right? So this is basically the same in Java. So let's say right. So we write a function not teen age, which returns true when teen, return false and false. Right. So I think we have our teen function here. Right. So we'll define a new function. So def not teen, and we'll give a parameter age. So if teen with the parameter of age returns true, or get so when teen returns true, or no, if teen returns false, we have to give out true. So if this is equal to false, we have to return true, otherwise false, like this. And another one. So if we try not teen, 13. Oh, wait. I think there's a problem with the teen function. Let me try. No, it should be working. So, no, java.lang.boolean cannot be cast to java.lang.number. Right. So I think I have to fix this. So if right, I don't actually need to compare, so because this is already a Boolean value, so if this will return true, I have to return I just need to I think it should be like this, false, true. So if I do not teen 13, it returns false. If I do 25, it returns true. If I do 12, it returns true. If I do 19, it returns false. Okay, great. So write a function leap year. Yeah, this is pretty standard, I guess. So I'll try my best to do this. So we have to write a function define leap year question mark, and we get a parameter of year, which will return true if year is a leap year, otherwise false. So how do we do that? Well, we have to check a leap year. Well, it's a pretty complicated condition. So a year is a leap year if it is divisible by 4, except if it is divisible by 100, in which case it's still a leap year if it's divisible by 400. Well, so I'll just check the pseudocode for this. So if year is not divisible by 4, then it is not, then it is a common year. So well, we probably have to use the condition like this, and then we type the expression. So if divisible, if 4 divides our year, so if this right, so no, I should just make this a simple like this. I should just make this a simple if or else statement. So if year is not divisible by 4, so if divides, if 4 divides year, so if this will be, if this is true, I'll have to, okay, so if this is true, then we have to do this part, so right here. So then I have to check again if year is not divisible by 400. So if 400 divides our year, oh no, if, I forgot about this, if year is not divisible by 100. So if 100 divides, so if our year is divisible by 100, then we should execute this code. So this is getting pretty confusing, but say enter. So if, and now we check if, yet again, if 400 divides our year, then we have to return true. Otherwise false, like this. Now we get to this part where we return true, and then we have to this, and I guess false, because that should be correct, but I'm not really sure. So let's test this out. This was a bit leap year. 100. False. Okay, good so far. 200. False. Let's just wait. 400. And we got true. Oh, great. 12 is true. 20 is true. And let's see, 15 should be false. Great. Super proud of myself right now, as I was able to figure this one out. So I'll stop streaming right now. I hope you learned something, because I certainly did. I had a lot of fun doing this, and in the next couple of days I'll be doing some more exercises, and I'll be doing this stream on, and I'll be trying to complete this online course. Thanks for watching. I hope I see you next time.